right, welcome to this programming video on this handguard in FeatureCAM. We're going to take a look at how we would program this handguard. It's going to be on a turn mill machine, so we'll utilize the sub spindle and take advantage of that. So we'll do a part transfer and all that. A little bit of context: this part is a handguard for a rifle, obviously. I want you to see, this is my stock right here. What this is represented as an extrusion. So this would be an extruded piece of stock, and then we would have our model, of course, for the machining. Okay, so let's take a look at what we got. So here's the handguard. The bulk of the shape is there. We'll have to do some work on the outsides of this, cut this with a slitting saw or some sort of tool like that, mill all these features around the handguard itself. So I'm going to go ahead and get into FeatureCAM and show you how this works. Now, if you're familiar with FeatureCAM, you know we have something called AFR. In this case, that's not going to work on a part like this, because AFR, which is automatic feature recognition, extracts features along the Z-axis only. So we'll be using the interactive feature recognition, or IFR, to be able to manufacture this. Okay, so I'm going to go ahead and hide this stock real quick and just kind of clean up the screen a little bit so we can see what we got. So we have some work here, as I mentioned, and then a bunch of things here. So let's just start with something not overly complex. We could start with these grooves along here, but we're actually going to be holding onto the part back here somewhere and machining a bunch of these. I'm going to go ahead and program it as if we're not really holding on to it, but you'll see later when we get to the transfer, I'll have to do some of these other features separately. So if I run FeatureCAM's new feature wizard, I'm not doing any turning on this part. All the bulk of the shape is there, so it's going to be all milling that we're going to work with. So we have turn mill here. So what I want to do, I'm going to go ahead and focus on like this face right here. So all these little triangles, squares, and circles, and see what we can do. So I'm going to do what's called a side feature, because none of these have a floor in the bottom, so they're not really pockets. So the interactive feature recognition will want to treat them as a side feature. So by checking this box right here, extract with feature recognition, we get into the interactive feature recognition, or what I'm going to call IFR. So I'm going to press next. The first thing we need to do is determine the orientation of the tool, or index the part to get the end of the tool perpendicular to the area we want to machine. So we want the end of the tool to be perpendicular to that face, essentially. So this dialog right here is showing us that we bring a tool along the Z-axis. That's not what we want. We want to work around the index axis, or index the part. Okay, so I can do this a couple different ways. I'm going to show you the easy way first. If I have a flat like I do here, I can take the tool and make it perpendicular or normal to that surface. So I'll go ahead and select that surface. And then what you see over here next to the setup, so this skinny arrows, the black arrows is our setup. And then you see a blue visual here. That's basically just showing you that if you were to do this like in a mill, Z-axis would be pointing up. So if we were doing this on a 4-axis mill, it would rotate and Z would be up. So this is just a temporary visual to show you the tool coming along that. So obviously it's going to come along the X-axis, but shows it, similar to like what you'd see in a mill. That's just a visual. This is going to go away. This is our setup. That's going to remain. This is just getting us aligned to be able to machine these. So index the part. So I'm going to hit next. If I try automatic on this, it's going to look for things missing walls and floors at that angle. So if I press next, it's going to take just a few moments here. And you're going to see that it's going to find all of the squares and triangle shapes. So it's not finding the circular shapes, because that's a cylinder and it's a small cylinder. If it was much larger, it would more than likely find it. but basically we're probably going to drill these anyway. We could go back and select these and put them as side features if we want. So, but I'll show you the whole feature. So in this case, I mentioned that I'm going to be holding back here somewhere. So I'm probably not going to keep these 5 features here. Okay. So what I'm going to do is if you select one at a time, you can add them in. But what I'm going to do is hit a select all, and it's probably just easier to remove the features that I don't want to do until we get onto the subspindle. Right? Okay, so it gives me those features right there. So I press finish, and if we take a look at FeatureCAM, right now I'm showing you in the toolbox the steps. This is our workflow for those of you who may not have seen it before, seen the software before. We define our stock first, then we can create geometry with CAD tools, or in this case use a solid as our geometry. Some features require curves, so you're going to see these triangles and squares are going to have curves that were created by the software. And there's some surface and solid tools, AFR that I mentioned briefly at the beginning, and then features. Now, I want to talk about that real quick before I jump out of here. But features are basically either mill or turning when we're in a turn mill. So turning features, you can just type dimensions to make holes, grooves, things like that. There are some that rely on curves, so we'll see on the mill features those will have curves, and then some part handling and some other things. But if I back up and go look at the mill style features, these are the same thing you'd see in a mill document. Holes, rectangular pockets, thread milling, facing, all defined by dimensions. And then from curve, there are several features, and that's the one I chose, was side from a curve. And the feature recognition is going to actually create those curves for me. Then there's something else here. I'm going to probably show you a group feature and patterning. So we have similar shapes around the part. So if I create them once and pattern it, it'll save me some time. But also I'll probably put them in a group because I'll have a bunch of individual features. And that way I can pattern the group and not have to go pattern all the individual features. Okay, so anyway, we'll take a look at that in a bit. All right, so that's what the features are. FeatureCAM is feature-based, and what that means is when you create features, you're creating multiple operations. So if I look over here in the results, you're going to see that I have not only the features, side 1, 2, 3, 4, 5, all these different things that are going on, but I also have rough passes, finish passes, already done. Sometimes you'll see 1 rough pass and 2 rough pass on the same feature. I'll talk about that in a bit. But FeatureCAM's already automatically selected tools, calculated feeds and speeds, and that's based on a table. So whatever the material is I made this stock out of, and then what is the tool made of? Is it a carbide tool, high-speed steel tool, etc., right? So it's actually automatically calculated for you. You can go modify the feeds and speeds table to suit your needs, but then the tool selection happened automatically and stuff like that. And then we'll also see some sort of information here. This basically says that this 1/8 inch end mill, so if you look to the right, you'll see that it's got a 125 stub rotary just to the right over here. And when I hover over that, it's basically was telling me that the tool is not small enough to clean up this. So I'm going to need a smaller tool. But I have a setting in here telling FeatureCAM that it's not allowed to select anything smaller than an 1/8 inch to do any roughing. And so it's just basically warning, says, hey, I'm not going to be able to clean that up. And so we'll take a look and see what size tool we're going to have to work with. Or I can go change the setting. But for now, we're just learning how to create the features so we can see them. If you look closely, you can kind of see a red outline. If I click on here, they turn purple. Purple is the color of feature, so we can see all these different features. Over on the left, if I wanted to simulate this, that's the next step. So after you create features, you do toolpath, and you can see that it's simulating. Right now we're just doing a center line simulation where it's showing the center line of the tool, how it's ramping down into the area and all that. I don't have any pre-drilling turned on. Certainly could do that, but I don't have it active as my default. So it's just going to mill them out by ramping and doing it. All right, so that's just a center line simulation. We have other simulation types as well. We've got a 3D simulation. So essentially, let's take a look at this. There's my stock. So this is the extruded piece that I mentioned at the beginning. That's exactly what my stock looks like. So I'm just going to go around. You see it indexed. And in 3D, we also collision check. So if I have a tool that's not sticking out far enough out of the holder, we'll see the collision, so I can go deal with that, stuff like that. Okay, so we're going to get back to all that in a bit, but let's just create the features first, then we'll deal with what we want to do with tooling and stuff. Okay, so the last thing would be, once you simulate, that's NC code would be generated. And you can see that actually over here. You're looking to the bottom right in my results window. Here's NC code for my part. When I simulated in centerline, it created NC code. Obviously, I'm going to have to extend the tool for actual manufacturing, but there's the NC code for the part based on whatever post processor we have. And you can see right now I have an Akuma Multus that has a B-axis head and a main and sub spindle. Okay, so, and then any changes you make, this will gray itself out and you need to resimulate things to get updated code. So that's like our workflow right there. The customizing of the manufacturing is where we decide our preferences and our configurations that we load in, you know, our depth of cuts, step overs, things like that. We can also switch tool cribs, change the post out, things like that from there. So just getting everything ready is basically what that is. So that's our workflow. Every part's the same, whether you're in milling turn or wire or something like that, right? 4-axis, 5-axis. They're mill features, they're turn features, they're wire features, and you just use them accordingly. So over here in the toolbox, we also have this part view, and that's where you'll see the items that we've created. So right now I have 11 side features. That's what we created. And if you watch in the graphics right here, as I hover over them, they highlight green. You can see exactly which one is which, in case you want to go make some modifications. Okay. Also, here are the curves that were created to the corresponding features. So curves 1 through 11. You can see them. I have a couple where I made the extruded solid to represent my stock. Couple other curves I created beforehand. So these are the curves that side features need. Okay, so all right, so let's just kind of move on. If I were going to accept that, we should probably go fix the tooling issue first, right? So if I go look at the operation list, I can see my tools over here and the feeds and speeds as well, see what feature name it is, and even what operation it is. So this particular tool, if we watch, there's an arrow right here, and we're getting a message that it's too big or unnecessary. So this is not a very big area. FeatureCAM's default is to pick a large tool like a 1/2 inch and then pick a smaller tool. So these warnings here are basically saying, hey, I'm going to skip these tool paths because it's unnecessary, or my tool's too big, I can't fit in there. So let's go get a better choice at this. So now that we kind of see what kind of part we're looking at, we can go make some default changes to our settings. Now these are in the features and manufacturing on the ribbon. So FeatureCAM is ribbon based, so you see that at the top, features and manufacturing. And configurations are defaults that you can create for your specific machining needs. So maybe you have settings for stainless steel, settings for aluminum, things like that. And that's depth of cuts and step overs and things like that. Your feeds and speeds are handled right here in the feeds and speeds table. This feed and speed table is, right now, this part is made out of tool steel. And you can see there's a bunch of different materials that come installed with the software, as is all these tools. All these tools that were selected were from a tool crib that we installed with the software to help you to be able to make your own tool cribs. You can see all the different materials, and that affects our feeds and speeds there. So you can modify those tables. I'm not going to go into that right now, but what I want to do is look at attributes. So this was a configuration copied into the document. They become the active attributes. So I'm not going to mess with my defaults here. I'm just going to mess with this particular file's defaults. Okay, so it's a milling setting that I'm looking at, and tool selection is the area. So why did it pick a 1/2 inch end mill and only an 1/8 and all that? Well, that's found in our multiple roughing area, and you'll see that by default, we're trying to use a 1/2 inch, so therefore you see the 1/2 inch there. and then automatically pick something that will fit the smallest radius. So we have the radii in the triangles and the squares, right? But our limit is no smaller than 1/8 of an inch. So if I were to say, okay, I'm good to rough down to like 62.5 or a 1/16, that would change the setting. Also, I could say, let's not try to do the 1/2 inch. Let's just pick a single tool to do it, and the smallest we can go is that. So we can change this. What you're going to notice now is when I apply this by just hitting OK, this is all going to change. Now it's all using this 62.5 rotary. Okay, so what size tool could I fit in there if I wanted to use a larger one than a smaller one? Well, I have an opportunity to use something on our geometry dimensioning tools called curvature, and I can click on here and find the radius of that. The radius is going to be shown right down here at the bottom in axis 2 actually, and you see it's a 187.5, so that's a 3/8 diameter hole. But let's check the small radius in here, see what that is. That's 15 6/10. So even here you're going to see on the 62.5, if I hover, it says, hey, this 16th tool is too big, I can't quite clean that up. So I'm going to have to go even smaller with that. Okay, but maybe I do that just on the finish pass, which you see as an option, right? So what I'm going to do is go ahead and get these set a little better. So I'm going to go back to the machining attributes. And the cool thing is once I have this set, then the rest of the features are all going to honor these settings. So I go back to the tool selection, go in here, use a single tool, but I'm going to say, hey, the smallest we can go is a 32nd. Maybe you don't really want to do that, but that's for roughing, keep in mind. So maybe we don't want to use that. And now you'll see that I've got errors because maybe I don't have a tool that meets the criteria to do that. Okay, so FeatureCAM's super smart, and it's looking at your available tool crib to determine what's available for tooling, and then of course these settings here as well. So what I'm going to do is I'm going to go ahead and say let's do a 1/4 inch end mill, or maybe let's do like a 187.5. Okay, so we'll do a 3/16, and then automatically select something down to a 32nd. Okay, we'll see what happens here. Now we've got an updated view, and right here on this rough pass we've got a red exclamation point, which is basically saying we have to deal with this. So if I double click on that, it's going to give me some options, but if I hover over it, I can see that it says I need a tool that has an sharp edge, so no radius on the end. I need one that's got at least 96 something in tool length and a diameter of less than or equal to 31.25. Remember, that's a 15.6. So this rough pass is not wanting to, we're trying to fit a tool in there that's too big still. And part of that could be our leave allowance for these features. Okay, so if I go in here and I go into the milling and go to my step overs, you're going to notice the finish pass leave allowance, or finish allowance we call that, is 50 thousandths. So we're telling the 3/16 in this case end mill to leave that much, and then mathematically, of course, as we're trying to go down to that smaller tool, it can't fit, right? So what if I change that to say 5 thousandths? And it's going to affect all my milling features. We didn't really see a change here. So what we could do is then automatically pick our own tool, and we kind of look at the hover again, and we see that a 32nd tool we need less than or equal to, right? So let's go look. If I double click here, that'll take me right to this feature, right where the tools are, and I'm going to go by end mill, and I'm going to search for 03125, and you see that I have a couple, but I don't have a lot of cutter length. Okay, so if we look at this tool, a couple things about it. One, it's super short, so my cutter length is only that. It's super tiny, right? So maybe you have like a 1/4 inch or 3/8 cutter length on this tool. So I could make a new tool and say it's, you know, an 031 carbide. So this is how we can make a tool, right? We're adding this to our tool crib right on the fly. and I'm going to say length of cut is 0.5. Maybe that's what I have. Then I'm going to modify these accordingly. I'm going to go ahead and stick this out an inch. The overall length is probably about 1.5 inches, so whatever your tool is, honestly, this doesn't really matter for what we're doing. Cutter length, that's the amount of flutes. So when I say length of cut, I mean the flutes, 0.5, and maybe it's a 2 or 3 flute, whatever, or 4 flute, whatever you have. The shank diameter, I'm going to match it to the actual end mill, and then there's no end radius, and then I'm going to switch it to carbide. This will affect the feeds and speeds because now it's carbide, not a high-speed steel tool, right? So if that's the one I got, and you see that doesn't make a lot of sense. It's sticking way out there. Maybe we do 5/8, probably not really that long anyway, that small of an end mill. But let's just take a look at that. So we're going to go with that. I'm going to create this as a new tool and say use that tool. And you see the red exclamations went away and everything goes. So really the creating the features is the super easy part. If you had your tool cribs all set up already, you wouldn't even have to mess with all this stuff. And then again, we get the warning that, hey, we're, I'm not going to clean up or whatever the warning is. It could be a bunch of different things. So let's see if we can simulate that now. Notice that my NC code is grayed out. Okay, I'm going to go back to the Home tab and choose Center Line. And so this is where you choose the simulation type. Press play. We're going to see the tool path. I'm going to go ahead and speed it up a little bit. This arrow shows where we are in the process. So when I do the collision checking in the 3D, I can see right where I'm at. Okay, and then we have all these that are running. So it's kind of automatically determining depth of cut and step over and all that. So you can see the purple is the original tool. This bluish color is the other tool, and then we have the last tool coming up as yellow, and they're basically just taking shallow depth of cuts, which I can increase and reduce machining time. And they're retracting quite a bit, but we're trying to clear an index. I can keep the retracts down lower. A lot of things I can do here. But let's watch this in 3D. Press play. Okay, so you can kind of see what the tool is. I'm actually going to play this to the next tool change, actually. And so I have something called tool colors on. So each time we changed a tool, a different color is selected. So you saw what the purple or the 3/16 end mill did, or was that 3/16, right? And so then here comes the other one. And you can see it kind of picking out the corners and doing all that. Watch right here again. You see it's doing it at multiple depths, which is probably good for this tool. But we might be able to just take the tool deep and reduce the step over as well. We have options to do that as well. Okay, and then we get down, and if you look, the arrows right here, these little warning triangles are kind of covering it, but basically saying, hey, we're not going to clean up. You can see that's a 46. So that tool is different, right? So it's really tiny. And we need to pull it out if it's going to work. You can see it's colliding, so the collision checking saved us. So I can go right to this tool, and let's go take a look at it. And maybe there's a better tool to do this. Again, if you have all these tools in here already, you don't have to do this. I'm just kind of showing people that may not have seen the software what we have. And so here we have an 046, right? Tool. Let's see what else we have in here to choose from. So do we have like an 0156 tool? I don't have one. Do we have like a 20 thousandths tool? I've got a tapered one, but it's not that. So maybe I should make a tool. So maybe you can get a tool. This tool crib doesn't have one. Maybe we can get like a 20 thousandths diameter tool or something. And so we can make a new one, and we'll say 20 thousandths. I'm going to say this is a 20 thousandths carbide, and then 0.25 length of cut. Go ahead and switch it to carbide right now. I'm going to change the shank diameter to match, if that's really what it is. It might actually not be that. It might be, an 1/8 inch shank or something, right? So we could try that. I have 2 decimals there. Okay, cutter length, 1/4 inch. Here's my exposed length. I'm going to try to stick that out, as far as I can. Let me hit apply. That's what our tool looks like. Maybe you do have one with that. More than likely you'd have something like that size for a shank. You know, who knows? Or you have this tool made, whatever. So the key is this is now going to be in my tool crib and available. So what you're going to see is all those areas that had that issue, they're the ones that I changed. You can see that they're now at this 20 thou carbide. So what I'm going to actually do is take this and highlight all of these with my shift key. And because this tool is already the one I want, I'm going to apply it to all these operations by right clicking and say, hey, let's override those tool paths to use that tool that I just defined. Okay, so if that works for us, then we can simulate it. We'll see if we have any more collisions. Again, I'll go ahead and speed this up a bit and play to next tool change. Okay, so we know the first two tools cleared. We'll get to the last one and see what happens. And we'll see if it even machines these or not. Okay, and it brings the tool out. I can see the arrow right there. So I'm going to go ahead and play it. You can see that little bit that's picking out to get in there, right? So we don't have to use the 3 tools, but it might make sense to with such a small tool. I could force it. I could change that setting, not force it. Change the setting to go down to 20 thousandths and probably just automatically select that and remove this operation entirely. But on this, it's probably a smart idea to run the 3 just because things are small. So I'm going to leave it that way for now because really we're learning how to program this. I'm also showing you some stuff about the software as well. Okay, so only in the triangle or the squares did that third tool get used. The other one was small enough that it could clean up the triangles. Okay, so what do we do now? All right, so we've got those, but we see that we've got another flat on the hand guard there, and a fourth one. So maybe we can just pattern these together, right? So I'm going to take all of these features and I'm going to put them in what's called a group. So I'm just going to shift select them because I like to pick things first. Go into my new feature wizard, milling, and I'm going to say, hey, let's group these. And I'm going to call them circles and or triangles and squares. I'll call that group triangles and squares. There's all the features. Okay. If I want to manufacture in a specific order, I can. I'm not going to worry about all that. I'm going to let it automatically determine how to manufacture it. And you can see all the different features, side 1, 2, 3, and so forth, are all contained in this group feature. Okay, then I can rename this group and we'll just say group tries and squares. Maybe I'll do SQ and a small s. Okay, so groups, triangles, and squares. And then if I want to just keep my list shorter here, I can collapse this, right? It's totally fine to leave it uncollapsed. Now I can take that group and I can pattern it around the index axis. So we're indexing around the z-axis. So I will pattern those features. Now I'm going to get all of them all the way around. So I need to choose a radial one, okay? Radial in the setup XY is what we're seeing here. Let's see if that works. I think I really want the radial around the index axis is the one I want. So let me back out, cancel this. Let's go ahead and delete this group for just a minute. We'll take all these features right here, shift select, do the pattern here, right there. Okay, so we have selected more than one feature. Please select a single, right? Let me cancel out of this real quick. So I'm going to hit undo and put it back in the group. I just want to double check my indexing. We're indexing around the z-axis, right? So that's what we want. Okay, so I'm going to take this and try to pattern this again. And pattern, groups. And I want radial. This is trying to do it in the XY plane, but let's try this, put it as 0. We want 4 of them at 180. Let's preview that. We see that we got the pattern around there. So you see all the features line up. So in this case, That looks good. But then you look at this and you're like, wait a minute, these are not matching, right? So the triangles are the opposite direction here, so that's not going to work. The squares and stuff would work though, but we're not. So we're going to end up having to program all of these, right? Just simply because of the way the shape changes. So we've done this face. Now we want to do this one. Okay, so now that we got tooling and settings and stuff all worked out, this should be much easier. So I'll go to the new feature, turn mill. So milling features, side features, extracting with feature rec. I'm going to say perpendicular, take the tool end perpendicular to that, so normal to that. So we see the Z pointing up like as if we were in a mill. Automatically detect them. We can see all the different triangles and squares that are going to be extracted. Okay, this one is actually getting the cylinders as well in this case, because we have small enough tooling now is why that's doing it, and it's trying to do it all the way through, which we're not. So what I'm going to do is just select the ones I want to keep. Okay, and if you mess up, you can just click on it again and deselect it. And we were going all the way down to about here, I believe, and leaving those 5. Yep, and then we'll leave the holes alone. Hit finish. Now we've got another set of features. We can put them in another group if we want to shorten this list up. You don't have to do that, but maybe I would put these in another group just so you can see that one more time, just to keep this part view from getting too long. And I'll put them in a group. And I could name them, you know, tries and squares 2 or something. I'm just going to leave them as group 1, group 2, whatever. Okay, so we see all the features, all the same tooling, except for we see that it's trying to pick this 46 again. No big deal. We'll select this. Yep, hold the shift key, not control, and say override all these. Now, if I just go change my setting and say, hey, use down to the 20,000s, it'll automatically do that. But I have it set bigger than the tool it's trying to use. Okay, so here we have that. And the reason it's picking a 46, which is larger than the 31, is because of the tool length. So, you know, just you can see how quick and easy it is to create the features and make a modification. So if we were to look opposite of this, we can see this one looks similar. We maybe could have patterned that, but we'll go ahead and just put them in groups, and that way we can kind of keep things organized. So I'm going to go ahead and do the milling on this one again. We'll do a side feature, extract. I'm going to go around. I'm going to say normal to this face this time. Okay. See the Z is pointing kind of up towards it. That's good. So we'll index properly. Click next. Go automatic. You'll probably find the cylinders again, like the first one didn't, because we didn't have tools that were small enough, if you remember. Well, I had the setting at 1/2 inch, and so I was trying to use a 1/2 inch tool. Again, we see that, no big deal. We can just select the ones we want. We're not having to draw anything. We're not having to do a whole lot other than just kind of determine what tools we want to use. So we're going down to about there. Yep, leaving those. Hit finish. Okay, look at the tools again. You see the 20s, and then this last little bit. So it's organizing this, limiting the tool changes for us. Okay, so you can see the 20 thou carbide. We got it. We could put these in another group again. New feature, just for organization. Honestly, I'm just going to hit finish. They're all in that group, and that allows me just to keep this a little cleaner over here. Okay, then lastly we have this one, and how do I know which ones I've done? Well, I can see the purple of the existing features, and I don't see any here. So that's how I'm able to identify where I haven't programmed yet. So we'll go ahead and do the side again. One more time, normal to that. Next, automatic, let it do its thing. Okay, and then we'll see that it selects them. Okay, automatic feature recognition is working. It's identifying them again, and I'm going to hit select all. and deselect these. Of course, I don't want the cylinders if it finds them either. So 1, 2, 3, 4, 5, I think we decided. Yeah, actually I don't think I'm doing this one. Oh, I am on one. Okay, I just noticed that I missed one on this. I'm gonna go ahead and keep it here. Okay, so we'll have to get that one on the sub spindle or go back and fix it. Okay, again, everything FeatureCAM does for us: feeds and speeds, step overs, depth of cuts, tool selection. I'm just going to go ahead and make this little change. Of course, if I just go change my attributes, I wouldn't have to keep doing that. Okay, but it's no big deal. It doesn't take a whole lot. Throw these in a group. I got the bulk of the stuff done. So group it and just hit finish. And I can collapse that. All right, so look at all the curves that are being created for us as we go as well. So a lot of curves being done. I just collapsed that. Let's just take a look and see if we have any issues. We'll run a 3D simulation. Let's see how this works, if it indexes the part and actually works its way around. Right now my simulation is not rotating the part. It is in the machine, obviously. So let me change my simulation setting here for us. It's just a view, and I'm going to tell it when I'm doing a 3D shaded, rotate the part when we're indexing, and then we'll start here and we'll watch this. Let me slow it down. You can see it, machine it, and watch the part turn just like it would in the turn mill. Okay, and we're basically getting all this. Okay, so this is essentially, the bulk of how we would do this. Again, if we had everything configured ahead of time with our tool, I added some tools into the crib. If you already have these, then it makes it a lot easier, right? Get your settings right, and software does the rest. We'll pick things for you. You can always change them if you want, all that good stuff. So anyway, so here's the finished result of that. Okay, so what else do we have to machine? So if we look at the model, let me single step this real quick. Focus right here. Actually, I think it indexed on us, but focus in this area. You see that flat? Our stock has this on it, right? So we need to deal with that. Okay, so here's what I'm going to do. I'll just run a tool along the sides of these. Okay, so if I go like this and say new feature, this will also be a side feature because it's an open shape. So another milling, this is going to be a side, extract with feature rec. I'm going to, this time I don't have a flat. I actually have this. I could use that to go normal to and line things, but I want to show you this if you need to pick a specific angle. Maybe you don't have a flat, right? So I can pick this edge on this and get my z-axis basically parallel to that edge. And you see that temporary visual again of the tool axis. We're good to go. That was 0 degrees. And I'm going to just tell it what I want to machine. And what I want to machine are these edges right here. So you can see when I choose select side surfaces, I get a video showing me how to do that. So I'm going to pick this. And I'm also going to pick this, and that's all I'm going to machine from this orientation with this particular feature. So I add those in. It's going to create a curve basically following the length of that. This is showing which side of the curve my tool is going to cut on, so you always want to check that. Same thing here. Hit next. Okay, and this is just saying, hey, make sure you check those, and we can see the top and bottom, and hit finish and kind of see what we get. All right, well, so let's take a look at that. So what I'm going to do now, we got so many features in here, I'm going to go find that. And you can see this side 44, that's the feature that it just made for those two flat, or those walls. And it's got a large end mill, a 1-inch end mill. It's grabbing the largest one in the tool crib because there is no restriction. So if I'm cool with that, I can leave it, or we can swap it out, right? So I can swap it with, maybe we want to use a 1/2 inch. So let's do that. Let me swap this, and I'll sort this by 1/2 inch end mill, and I'll do a long flex. I'm going to use another 1/2 inch to cut some of this other stuff. Use this same tool. So I'm going to get this long one. Okay, you'll notice that it's set, and the finish pass, if I look at it, automatically updates to that tool as well. So it's using the same tool. So what I'm going to do is I'm going to put what's called a breakpoint right here while I'm programming. That way I can run everything really fast. You're going to see it work down the list. And these warnings are something about tool slot in the machine. Everything goes in tool 1. Basically, you can just ignore these. These don't stop you from machining anything. But you'll notice as we go, this is going to come down, and we're going to get to this point. There's the arrow. I can see it right there coming down. So let's see. I'll slow it down just this last little bit so you can see what's happening. You see the simulation paused right there. So now I can go simulate this and see what that did. Okay, so now it milled those flats for me. It did a lead in and a lead out, which is part of my defaults. It climb milled and did that on the rough pass in this case. It can go bidirectional if you leave the default, but that works out pretty good for us, and we've got those flats machined. Okay, all right, so what else do we have? Well, we need to machine basically the top around this, and then we got a sharp edge right here, so we're going to have to cut this. I would want to use the side of the end mill to get this stuff all the way back to here, and then go ahead and take it, swipe across the front of that to clean up that corner. And I want to use that, maybe that same 1/2 inch end mill possibly, right? So I need to get oriented to do this. Okay, so what I'm going to do is a new feature, milling. It's again going to be a side because none of these are closed with a floor. These are closed but they don't have a floor, so extracting it, side feature is the one. So I'm going to do the side feature again. This isn't the case always. A lot of times you're doing pockets and bosses. It just depends on your model. And I want to index, and I'm going to index here to there, get my Z, move that out of the way so that shows the indexing is correct. So we're at 270 degrees basically. And I'm going to select the side surfaces again, and I'm going to pick just these upper ones, and then I'm going to pick this. And the reason I didn't pick these is because this will help me with my top and bottom when I get there, so it'll do the whole thing. I don't have to select those. And I also want to include this and this in there, and I do want to machine all that, and so I'm going to add those in. And those will probably break this up into 2 curves, one to roll here, one to cut there. It's not going to hurt anything, and sure enough, I see the 2 curves. Here's my arrow showing side control for that one, and my arrow showing side control for that one. It'll continue to machine these, and then I can see the top and bottom. And in this case, I might want to extend it down just a little bit below this edge because that was the lowest edge. So maybe I go to like -450. And so we're going to have something around 800 and something, almost 900 total depth. So when you see, there it is, 867, I hit finish. Let's see what tool it picked. Right now it's trying to do the 3/16, 0. That's that setting that I put in the machining attributes. I'm going to go ahead and tell it to do a 1/2 inch and then 0, and that'll actually allow it to pick the 1/2 inch tool and then automatically try to pick something. So here's our 1/2 inch tool right here, and then automatically pick something smaller to try to reach basically in that sharp area. Obviously we don't need it, so I'm going to get rid of the second tool altogether because I'm going to machine that with another tool coming across the front of that anyway. So I just need something that's small enough that will kind of reach in here and clean this up, right? So I might want to go with a 3/8 tool or something. Let's see what this looks like with the 1/2 inch end mill. So we can see now that I changed that setting, got a 1/2 inch. I want to use the same 1/2 inch carbide that I was using before. Okay, let me uncheck this right here. Here's my 1/2 inch carbide long. I'm going to select that same tool to use that I did these flats. And let's just see what happens with this now. If I pull this down to the bottom, you can see the order that things are happening. So it's ordered down here behind that. I could change the order, flip these up here and have it do the other portion first. But let's just take a look. So I've got the breakpoint on again, keep in mind. I'm going to go ahead and run it fast just so we can see it. There is a way for me to take a snapshot of things that are already done and I can turn them off. I'll show you that in a minute. So it's running through. I'm almost there. Here comes our breakpoint. Okay, now the simulation pauses and I can slow things down again. And I can take a look and see what it did. And then we'll see it index. We'll see what it did there. So it's machining that one, getting all that out, right? And then you see what we have left. So we could come in here, as long as this tool is small enough to give us the radius we want, then we'll come in and swipe across here. Okay, so I'll go ahead and do that right now. So what I'm going to do in this case, I'm going to go ahead and hide features from view for a minute, get them off my screen. Essentially, I want to use these to give me the feature. But if I use these where they're interrupted, it will create two separate features. And what I want is one continuous toolpath across here. So I'm just going to manually go in here and draw using my model, using my tools here. And I'll just go across the bottom here. That gives me a line which could be used to make the feature. So this is going to give me the shape that I want, and I'm going to do a feature. But now it's at 0, so I got to make sure my index angle's right. I don't want to use feature recognition here. So hopefully this is aligned for me. And you can see that it's trying to do it sideways, right? So what I'm going to do is I'm going to hit finish on this real quick. And I'm going to go to the tool axis, and you see it's trying to do it with the rotary Z, come along there. So I'm going to change it to rotary X and hit apply. And now you see the feature looks like this, and my arrow is on this side, but the dimensions are off, right? So I need to just move the feature up, whatever this is. I'm just going to go 1/4 inch. I can measure, of course, but I'm not going to right there. You can kind of just see it visually. I can say, oh, okay, let's make it 1/2 inch. Just something that represents what you're going to machine, right? So I'll say raise it 1/2 and go 1/2. Okay, and I'll hit apply, and there's my feature. You look at the side control, it's on the correct side. I'll preview just this tool path alone. We can see the tool right now. This is just showing center, and that's going to try to machine all that because the roughing is on and the finishing. I don't actually need the roughing, so it's looking at the stock and saying, hey, you need to machine all that away to here, which in this case is not the answer. So I'll just go to my strategy and turn off the roughing, and then we'll see my finish pass. With a large end mill, notice how big that end mill is. In fact, I can look right down here and see in my simulation status, there's a 1-inch end mill. Okay, so we probably just want to use that same 1/2 inch end mill, right? So FeatureCAM's picking the largest tool that'll work in this case. There's the 1 inch. I'm just going to go ahead and take this right quick and say we want that one, and now we're good to go. So now we can do it. Now let me show you how we can take a snapshot of all this other stuff and not have to keep watching it over and over. So I turned all these other 3 features off. So while you're programming, this is handy. So I've got all this stuff I've worked out. I want to simulate it one time now, and then I want to basically take have the software start the simulation at that point for now, and go with it. Okay. The one thing I won't see is all the operations here. Of course, I wouldn't be posting the NC code without them all turned on. So keep that in mind. This is just while you're programming. We don't want to keep repeatedly watching this stuff over and over and over and over, right? Okay, so we're going to go ahead and let this finish up. I guess I could speed it up a little better. And the way I can do that now is I can go up to my results and use the results as a starting point. And if you notice, I'll eject the simulation and single step it. You'll see that all these are already machined. So because I put them all in groups, I can deselect those groups and then turn on the 3 features that I want to simulate. Single step, you see all the other stuff is done. I can see the result already, and then I can see what the result is of my machining. So you can see that it's breaking this up by depth of cut. I could set it deeper and change the step over to something smaller, but you see we get that result and we're pretty much there on that face, right? Okay, then of course we will have to deal with the slitting saw. That's the word I'm looking for, the slitting saw on here. Okay, we'll get to that later. We've got a couple other features right here that we can do, and then this one runs into the slitting saw, so that one's going to be kind of interesting to do. Looking at the model, it doesn't really make sense how they've got this modeled. Looks like they're cutting on the inside of that somehow. So this is probably actually a forged part, to be honest with you. But yeah, because we're not going to be able to get a tool in there necessarily. Okay, so let's go ahead and do these couple. You can see that's obviously something weird with the part, so we're going to just kind of ignore that for this particular instance. Okay, so we've got side feature and extract with feature rec because it's missing the floor, right? Normal to this. Press next. Okay, I'm going to go automatic. Let's see what it comes up with. Okay, so it came up with a few things. That right there, something here, something, they look kind of weird, right? So it doesn't always work with automatic. So what I can do is do a side surface and pick these walls. I'm going to go ahead and add these from the view that I can see. Then I'll rotate around here where I can't see the others, and I'm just holding the control key when I'm multiple selecting. Go here and here. Rotate around. What am I missing back there? Nothing there, but I've got a few more walls to select here, here, there, and then here, here, and there. I'll add those in. Okay, next. Side control, that one's backwards. I can see that right away. And then this one is also backwards, so I can flip it. Okay, so now we're getting those in here. Yes, they're correct, and hit finish. Okay, so we've got the features to cut those. It's got, trying to do the 1/2" end mill, blah, oh, sorry, that's the other ones. It's trying to use the 3/16. We're not going to be able to clean up. We know what we did before. So let me show you what I'll do in this feature. So I'll say, hey, let's use the 3/16 and then the 20,000ths. Okay, and we'll see what happens. So that one, it's got the 3/16 and then the 20,000ths are automatically there to clean up those. Okay, so that's worked out. Okay, so we got all that. So we could simulate all this now and update our snapshot if we wanted, right? So get all this done here. I'll go ahead and speed it up just a bit. Got those all machined, and then I could go in here and use these results as my starting point. So it's just an update, and then I can turn these off. Okay, and then we can program some other stuff. Okay, so that one was unique because of this step. Then I've got this one here and that one there that kind of match on the other side. So let's see if we can pattern those or not. So I'm going to want to go, this is going to be 0 degrees, so I could actually, I don't even have to mess with the indexing, but I can do it. Side feature again, extract, around or normal. I'm just going to say 0 degrees. I know that 0 degrees is straight up because of my setup. My x-axis is there on my setup, so I already know that. I didn't have to pick it. See what automatic does, just see what it picks. There's nothing wrong with looking at it, right? Didn't quite get what I wanted. It's trying to machine all these, including these little grooves. So we'll go ahead and use the side surfaces again. Again, this is super easy here. Bang, bang, those three. I'll go ahead and instead of patterning, I'll just go ahead and create the feature on the other side. All in one feature. Add these in. Okay, next, just check my side control. There's my side control for one. side control for the other. It says, yep, they're checked. And then maybe adjust the depth just a little bit, just to make sure we cut a little deeper. So hit finish, just like we did on the other one. Now we're done with 3 sides of this part completely, except for the slitting saw. And then of course the sub spindle work. Okay, but here's our simulation of the new stuff, and look at it picked a large tool again. So we'll go swap that out for the 1/2" end mill. I can see that, no big deal. FeatureCAM is just trying to save you time by picking the largest tool, and I'll just sort by 1/2". And I know this is the one I wanted. When I hit apply, you see the finish pass updates automatically. So any roughing that needs to happen. Okay, now I'll show you here where I'll take a deeper cut and a smaller step over. I'll do that on this one. Okay, so I mentioned it. You see it's kind of working its way down, as you might do in a toolpath, right? And it's just basically using a depth of cut limit. All right, so let's go change that. So the good news is that's one feature with both, so I can change it for both. And what I'm going to do is reduce the step over. This is 1/3 of the tool. That's a 1/2" end mill, and 33% of that is that number. So maybe I want to reduce that to like 100,000 step over. Okay, I'll hit apply, and then on my milling, I'm going to take the Z increment. So my feature is like 800 and something. I'm just going to put in 1 inch here. Anything larger doesn't matter. It's only going to go whatever this dimension is. But I'm forcing the tool to go to the floor, and I didn't have to type that exact number, right? So let's watch this again. Single step just to kind of get it started. Now we've got that 1/2" long end mill that we've been using. Smaller step over, deeper cut, right? And then same thing over here. It's bi-directional roughing. You can turn that on or off. It's on by default. You can make it off by default. And we're getting all this machined, right? Okay, so then we would do this slitting saw area, and then transfer it and all that stuff. So the slitting saw, that's going to be a tool that we're using like kind of the side of the tool. So what I'm going to do is I'm going to basically pull a curve off of this model manually. Or let's see if I can draw it. What do I have to work with? Okay, just looking at this together. Okay, what I'm going to do is just pull one off the bottom edge right here. So creating curves can happen with a curve wizard too. So curve wizard right here, I'm going to actually extract a curve off of here, surface edges, hit next. Okay, everything you see is because it's visible in the graphics window. And then I want to get rid of that out of the graphics. Okay, so what I'm going to do here is I'm going to isolate this face right here. Actually, let's take this one. And I can isolate that by just doing a hide unselected kind of a thing. And I'm going to pull the curve off of this edge only. So now that I've cleared things off of the screen, it makes it easier for me to see what's going on. Okay, so I'm going to go ahead and take this edge right here and make a curve. This is good. I'm going to call this, we'll call it slit 1. Okay, so I'm going to do like a slitting saw or something in there. All right, now I want to extend this curve a little bit. So I can extend it somewhat using geometry tools, and I'm just going to kind of freehand pull it out here and maybe back it up here just a little bit if I want. Something like that. So that gives me a little bit longer curve to drive the tool path, right? So I'm going to go ahead and come back here and show my actual solid so we can see it. There's my curve. I need to know a depth here essentially. So I'm going to measure this with just a dimensioning tool just to get an idea roughly. So I'm going to, okay, so we'll go like 1/2" on that. And then what is the depth this way? Or the width of the slitting saw that we're going to have to use, 1/8 inch. Okay, 1/8 inch by 1/2 inch and whatever. Okay, now when we do this, this curve is going to drive the tool, the center line of that, the center of the tool, so the center of the 125 is going to be where this curve is. Okay, so I'm going to move this up a little bit. I'm going to move it along the y-axis. Okay, so I'm just going to transform this curve only along the y-axis, and I'm going to move it up 0.0625. And I'm going to move it, hit preview, and you see there's my curve, and I hit apply and OK. Now that's right in the middle. Now I'm going to use a feature that is a milling feature called a groove, and specifically an inside-outside groove. Okay, because we're going to use a slitting saw or a keyway style cutter if we have whatever we have that'll work. There's my curve. Okay, now right now the tool axis is off and it looks like a slot, right? I'm going to go ahead and hit finish here, and I'm going to go mess with the tool axis. First off, I need to change it to an inside-outside groove, and I'm going to hit apply. And now you see that the feature changed shape, and I can see that my tool axis is still up. It's like upside down. So I'm going to get my tool axis, and I'm going to specify the index angle there. And now you see the groove. It's a little bit wider and not quite as deep as I want, but that's found on the dimensioning. So I'm going to go the 125, and then I determined I was going to go like a 1/2 inch, right? Hit apply. There's my inside-outside groove, like so. And then if I have a tool that's too small, so here's an 1/8 inch, and I do roughing, I can have it step over into it. So we could do like 50 thou step over or 30 thou step over into it. Okay, and if I had a tool that was too narrow, it would actually go ahead and modify the tool path and cut the center out and then up and down and work its way in. So I'm going to go with that. And this, let's just preview what this looks like. It automatically selected a tool again. Make sure that it's going to fit. Okay, so right there we can see the slitting saw. It's a pretty large diameter, and we might run into that down there. We'll find out. But there's the step overs. We got lead in and lead out, bi-directional, all that. Okay, so let's take a look now. Go to our 3D. Remember, we've taken the snapshot. Okay, so run those out. I'm going to go ahead and pause this and run this to the next tool change, speed it up. Okay, now here comes our slitting saw. Index is the part. Comes down, and I can change which direction it goes, but you see it's cutting the slit in there. And then there's a retract position right here. Everything was good until that last little retract, right? So let's see where that happens. So I'm going to play to next tool change, and then I'm going to go play to next operation, because I have 2 operations. So you see on the rough, it retracted too close because of the large size of this. Okay, so we can change the step over or the lead in and lead out on this, on the step overs tab. So right now it's doing a small step over. So let me preview this for you. You can see right there it didn't do anything and it retracted, right? So what I'm going to do is set a plunge point over here. This is representing the tool diameter, and I'm going to set a retract point over here, and that circle represents the size of my tool. And we'll see if that solves that issue now. I'm going to go play to, whoops, I'm going to go back to 3D simulation. So nothing's wrong, I just got to get things to make it work, right? So all the modifications that we need to do. All right, so here comes the slitting saw. I'm going to run this slow. Let's go index. Cutting the slit out. And then it's got a finish pass that we actually don't really need. So I'm just going to turn it off because the rough pass did everything, right? Or you can leave it there just to make sure. Okay, so now we've got that. So I'm going to go ahead and run it. We'll take a snapshot of everything again, update the results to this. Okay, so if that's all we were doing on the main, that would be great, but we have a bunch of slots and stuff to do. Let me just show you that on here, how we would do that. So obviously going to try to go all the way down. Remember, we're holding onto the part, so I want to go ahead and change this. All right, so, or restrict how far down it goes, I should say. So I'm going to go turn mill, and I'm going to go side feature, extract with feature recognition. Okay. Again, I'm going to go normal to this. So the end of the tool perpendicular to that. And I'm going to see what automatic does at that orientation and see if it gets these or not. If not, we can add all those in. So let's see what we got. So if I keep this and this, you see that it's going to machine in between those two. That's good. Okay, it's also going to try to do this here, but this is already done. So if I hit select all, then I'd have to go deselect like this and this and this and that. So however you want to do it, right? So I'm just going to go ahead and select these items. I'll just go from this view, pick all of these all the way down. And what it's doing is making curves that oppose each other, and it will keep the tool in between those. And just keep going. A lot of times your parts, since they're not necessarily as complicated as this, you don't have to do all this picking that we do, but this part's got a lot of different like interrupted faces and things like that. So let's see how far down I want to go. We'll go down to about there, and I'll hit finish. Okay, so that made all these different side features right here. It's going to, so it starts with side 49 and 50 and all that. You see that it's using this, trying to use that 3/16 and whatever. Well, what's the gap? Remember, that's using that because I told it to try to use the 3/16. So if it doesn't fit, it's going to skip those operations. So that actually fits on size in there. Okay, but we're going to want to clean that up better, so we want a smaller tool. So you see that it's picked a 171. So on all of these features, I'm going to have to make a change to the machining attribute setting right here and tell it to use like an 1/8 inch tool. Okay, but then that means I have to change it on all of these. Okay, let's see what tool it is specifically. Okay, it's a stub, whatever. Okay, so only that one operation got changed. You can see the 1/8 inch right here. Then these are all using the 3/16 and all that. So what I'm going to do is I want to copy settings from this one to all of these. So I'm going to right click on here and I'm going to copy this onto my clipboard. And then I'm going to highlight all of these operations and I'm going to do what's called a paste special. And I'm going to copy the machining attributes from the feature on my clipboard. That was side 49 that I copied. And then I highlighted all of those and I want to copy them onto all of those. And I want it to do everything, all the attributes that are in effect. I'm going to apply it to those features and we hit finish. And notice how all of those now change to use the 1/8 inch end mill. Okay, now we had some other operations that were using an 1/8 inch end mill, if I remember. Nope, we weren't. Okay, so we're good. So we want to run this now. So we don't need to run the inside-outside groove. We don't need to run side 48 anymore. We want to just see these because remember I took the snapshot. Okay, and let's see if we get a collision or not. So it indexed the part. Sorry, my view's off. And it's cutting those all the way down, right? So we didn't have any collisions, so we're good with that tool. And we're basically got all this stuff done for the most part. But what are we missing? The holes. There's some holes that bolt in to hold this together when you mount it onto the rifle, right? And we got the holes, the circles here. So let's see what happens when we try to do holes. Okay, this is actually really easy. Turn mill features. We want hole feature. Extract with feature rec. I'm going to say we want to do them around the index axis, but I'm going to say automatically find them all. So anything that's not aligned with Z, even if it was on an angle this way, this automatic method is going to find all of these, and you can see recognize and construct multiple holes. That means different types, like this is a plain hole and this is a counterbore hole, right? Let's see what it comes up with. So this will take a minute because there's a lot of cylinders for it to look at. Okay, so it found all of those really well. One thing I notice here is that it's doing these separate, which is fine because we got the countersink. So it's actually going to do these as separate holes. If I wanted to drill through all the way on this, I could change that feature, but we have the countersink anyway, so we might as well just pop it through each side. So I'm going to keep these, and so I'm going to hit select all, and I'm going to hit finish. And now I've got all these patterns of holes that we could put into a group. We could put all these into a group for the grooves on the handguard, right? And they're not really grooves, but they're, you know, the notches there for the Picatinny rail. Okay, so we could group all this stuff up if we wanted. Why don't we just go ahead and do that? And I'll do a new feature. I'm only doing this because there's so many of them, right? You don't necessarily have to do that. So that's group 4. I could give it a name and say it's, you know, Picatinny notches or whatever. And then here's my hole patterns. I could stick all of these hole patterns and say they're all the holes into a group if I wanted. That's just if I want to, right? Okay, so let's simulate what we've got now. So remember, we still have the updated view of the stuff we've already ran. Here comes the Picatinny, and then super fast. Let me slow that down. There we go. The indexing, do the holes. Okay, now I selected all those. Obviously, we're going to collide with the sub spindle if we do that, so I would maybe just redo that pattern if it were me doing it again. Select all and unselect those. So I probably better do that actually. So which pattern is that? That's going to be pattern. Let me hide the solid for a minute. All right, which pattern is which? Okay, so it's this first pattern. I'm going to actually delete that pattern, and it actually leaves the single hole. So it deleted the group first, then I got to delete the pattern, and then delete the single hole, and then I'll redo that one more time. That was just me not paying attention. So this is a good way to see how you can redo things, right? So I can do the turn mill again. We'll do hole feature, extract with the IFR or the interactive, let it do its thing, find them all. It's going to find all these again. I'm just not going to keep them this time. I'll show you how I'll go about that. It's probably going to be easier for me to just hit select all, and then I can go deselect, deselect, sorry, deselect, deselect, deselect these. If I'd have just done this the first time, we would be good. Okay, so those are out, and then I'll take this one and this one and that one and that one and that one and that one out, and lastly that one and that one, and hit finish. Then I get pattern of hole 4, and then I can regroup those again if I want. Next group, just hit finish. Okay, so we're basically ready to put this on the sub spindle. Okay, so we got all these features done. Obviously, we're going to want to post those before we're done. So what I need to do now is put a new setup on this. So I'm going to put a setup on the other end. I also need to do a cutoff unless this is a slug to the length we want, right? I'm going to treat it as if it is that. We're just putting it into the jaws, and it's an extruded piece, probably saw cut, all that good stuff, right? Okay, so right now my stock is set a little bit longer than this, so we'll face that off on the sub spindle. Maybe that's what they want for mounting to the rifle better or whatever. Okay, so I'm going to do a new setup. The setup is going to be on the, so we're going to do a sub spindle setup. I'm going to place the 0 on the other end, and then you see it out here. Now that's because it's on the end of my stock. Okay, so if I show the stock again, we'll see that it's out on the end of the stock. So if I want to move this down, I just need to know where. So I can do an interrogation for the location in the Z from my current setup, which is setup 2, and just touch the end of this part and give me a number. So it's minus 194. So if I wanted to, I could put this down here and say move this down, hit apply, and okay. All right, now we want to face this, so that's going to require a turning feature, right? We'll turn it, we'll do a face, we'll hit next. The thickness is the 0.194, okay? Outer diameter set off the model, inner diameter. We don't have to go all the way because we've got the cylinder through. I'm just going to put it to 10 millimeters diameter. Okay, so we see it's huge, right? So what's the outer diameter? I'm going to give that off the part itself. Oh, sorry, I've got wrong number. So I think the stock is somewhere around 2.5, and we don't want to go to 10 inches. I was thinking millimeters for a minute. We'll do a ½ inch. So we'll go from 2.5 down to ½ inch. You can see I can increase that 750. Whatever. Okay, so we'll just face that part off. Now we need to make sure that rough and finish is on. So turn the rough pass on, and then it'll face that. Okay, so now we've got that. Now let's just take a look at this up to this point. Okay, first off, I've got to go back to setup 1, and I need to, let's go ahead and collapse these groups up a bit. Just kind of shorten up our list here. Okay. I'm going to go ahead and, I guess I didn't put those in groups. Okay, I'm going to go ahead, and what I want to do is do a cutoff feature, or just a transfer. So if I'm doing a cutoff with a transfer, which I'm not, I could do that, or just a simple transfer. So that's called, that's a turning feature, and that's in the part handling. The part handling, we have multiple operations here. We can do a slug transfer, a reverse slug transfer, bar pulls. We can turn on tail stocks and steady rests and a bunch of other stuff. But basically, I'm just going to do a slug transfer, and it wants to know how much of the part to grab. So I'm probably only going to be able to get a couple inches of that. You know, maybe my jaws or this, or maybe we're grabbing all the way down. I don't know. Okay, let's take it like as if we're going quite a ways down. We'll go 6 inches, and then what I'm going to do is just put a number a little bit larger than that for it to rapid to that point. Actually, let's do 6 1/4. Rapid to a 1/4 inch before, then feed down and grab it and do the transfer. Okay, so let's see what that looks like in a machine. So here's a machine simulation. Okay, so now I've got a bunch of this already simulated. You can see the parts sticking out and whatever. We'll simulate all this, but let's just show you the transfer real quick. So we got some machining to do here, right? So some of the slots and all that. There you go. So if we hit the head or anything on the jaws, we'll see that. Let me go ahead and pause this, slow it down a bit. Now we've got the holes. We're drilling the holes. See it indexing. Hopefully your part doesn't flex too much. Maybe you drill it and then mill it. Or, you know, if you weren't going to do this and you had a tail stock on the machine, we could put the tail stock in there. Hold it. And there went the transfer, and then here comes the facing on the other end. So let me pause that right before this transfer. Okay, so we'll run this again. I'm going to run it fast just to get through the Here's the machine. Okay, and it didn't pause. Hang on just a second. Put one right here too. Sometimes you need, if you're going too fast, sometimes it skips the breakpoint. So you can just put another one right there, and usually it'll stop it. Okay, there we go. Okay, here comes the transfer. Grabs it, pulls it, goes over there. Facing. And then it's going to try to run the whole thing. So I'm going to turn everything back on. Let's run the whole thing and see what we've got. And so by putting them in the groups, you can turn the groups on and off. That made a difference. So what I'm going to do is clear this starting point back out. And we're going to start from the very beginning with machine simulation. Okay, it's going to take a second to load the machine up and get these features ready. Okay, it's just getting the machine loaded. So this is a B-axis head, just a single head, no lower turret on it. And these are all the triangles and squares, I believe. Yep. Okay. I'm going to go ahead and okay, so we got a collision. So there's another one. If we got a collision, something hit, probably the jaws on the head or something is showing a collision right there. Let me see what's happening. Okay, so sometimes portions of the machine can get in the way of your view, so you can hide them. And I can see what's happening. And it looks like my tool is too short. Okay, so where are we at in the process? If I go look for my arrow, there we are, side 47. Find it, there's side 47. Okay, so we ran this before we machined that. So we had programmed to machine this, but this was being run before anything else. So that's because it's using this same 3/16 as all these others. So what I'm going to need to make sure to do is to do all the flats before that, the bigger flats with like the 1/2-inch end mill and all that, right? So if we find those, remember these are 44 through 48. So if I just take these, and we probably want to do those early in the process anyway. Let's say I do that first. Okay, that's going to be the first tool that comes out. And I can manually go order things as well. Okay, here comes the simulation. Okay, I'm going to start slowing things down a bit. Remember, we're in the machine simulation. So I solved that gouge by reordering some of the operations. Okay, let me hit the whole machine again. There we go. See the whole machine just by hitting show all. See everything that's going on. But we're going to want to look in there a little better. Go ahead and speed this up a bit. So a lot going on here, right? If we have any collisions or anything, like I said, we'll see that before we get to the machine, which is nice. Okay, and we're getting into the area where we're still cutting the triangles and circles and stuff. Okay, so here come the flats. Now let me slow it down a little bit. Finishing up the triangles. So on and so forth. There's the slitting saw. So right there, my retract. I don't think we hit on anything. I think that one's just it was maybe just went too far, sent the head up a little too far. That's just a simulation thing. Your machine's obviously not going to do that. Okay, and then are we hitting? Nope. I think again it's just a travel thing. I think we're exceeding the travel limit on the machine is what that is. Okay, so which is nice. You can see that right there. All right, let's see. So slitting saw. Then we go into the holes, I believe. Oh no, all the little Picatinny notches. And there's all the holes. Let me slow this down again. We're getting close to the end. I want you to see the transfer. So it's spot drilled and drilled all those. Okay, and then we're at the break point. All right, now slow it down. Transfer, pull, face off, and continue with the part. So what happens is you end up just doing the same thing as we did, the same process as we did before on the sub spindle. This video is a bit lengthy, so all you have to do is make sure that you activate setup 2, and then that's your sub spindle, and you can go and finish programming the part just like we've done all along. Side features, index it, and finish the part. And then your NC code all generated, and you can save it and post it. Thanks for spending the time watching this, and look forward to sharing other things with you in the future. Thanks.